Okay, we are live. We're doing
Hey,
it.
Josh.
Can you hear me?
Yeah.
Hey, good morning.
Good night.
Yeah, good night. It's very, very, very early for me. Hey, we're live. We did it. We got this thing done. We just saw each other. We were just in Vegas. Did you recover? Are you sort of
I
rested?
recovered. I managed to not sleep in 2 days, and basically I fell asleep, and I was just So time zone shift is okay for me, and I'm fine. I'm fine. And you?
Oh yeah. I mean, it's overwhelming. I didn't think I was tired until I got back, and then suddenly all these ideas about, oh, I'm gonna get all this done, this stuff, it never got done. The whole weekend.
No, that was fun, and I really like your. I mean, you are doing usually live demos, and you are well known for that. But live demos with AI are next level because that introduce a bit of uncertainty, and it was quite impressive to see you manage to do it.
Thank you. Yeah, that was. I mean, that's the prompt engineering that people talk about, right? It's not a joke. You got to figure out what you can say to get the system to do what you want. It's not easy. Yeah, that was. We had some very. We did a lot of sample code for the keynote. We did a lot of code for the Spring AI talk, and for the keynote in particular, there was you know how it is. You start with these big ideas, and then time catches up with you, and now your big ideas, you have to make them smaller again. And because you're on such a tight schedule, there's no room for risk, and so one of the things that we spent more time than I would like to admit working on was getting the AI to do exactly what we wanted, when we wanted it. Like not later, not after a few different attempts, but exactly the same thing every time. But it can be done. It's just it takes like any engineering effort, it takes validation, hypothesis, and then results in validation.
And you have to pray that they don't update the model too much because you don't have everything locally.
Yes.
So yeah.
Well, that's the thing. So there are great models that are local, and when I go to Europe, I talk about Olama, right? Because we in the keynote, I think we were using OpenAI, but we could have used Gemini or Azure OpenAI or whatever. But there's so many really, really great models that are completely local, no internet, completely uncensored. You can ask it to use bad words and anything, and it's for a lot of tasks, for a very, very large number of tasks, it's just as good as OpenAI. I'm not saying everything, but for a lot of companies, especially if you're in Europe and you have concerns about privacy, and I think the rest of the world should have these concerns, but Europe, they already do. It's in the law, right? GDPR and all that. And here in the US, if you're in a bank or if you're in a hospital, you don't want to send your data over to OpenAI, or maybe you do, but you want guarantees, But with right now, it's very painful because there's a million different choices. Which one do you choose? Do you remember 10 years ago, 15 years ago, it felt like every week there was a new NoSQL database. Now, maybe there's Elastic, Neo4j, Mongo, Redis. What else? Couchbase.
So many options, yeah. And
there's not that many,
And it was fun to see Ron Johnson on stage with you and Dr. Mark Pollack. That was fun to see the three of you on stage.
Thank you. Yeah, that was also that for me. That was I mean, I'm like you, right? I mean, you and I are just people that work on the Spring team, but he created it. Like he and Jürgen, they said they changed our world. Um, we live in a wonderful place where people like that exist. And you work with Jürgen. You're on the Spring Framework team.
Yeah.
You're Sebastien Deleuze. Sometimes I forget. Maybe one person doesn't know who you are. So in case for that one person, maybe who doesn't know who you are, I've never met such a person. But if they exist, I think we should help. Who are you? What do you do?
I'm Sebastien Deleuze. I'm working now for 10 years in the Spring Framework core team with Jürgen and other members of the team. Yeah, 10 years, man. Yeah, I'm that old. so many time. And yeah, I have started working mainly on the web stack, a bit on reactive, and more recently I have focused on runtime efficiency. I have been leading the Spring Native experimental effort that then I've incubated and is now integrated into Spring Boot as the official GraalVM native image support in order to start faster, consume less memory, etc. And I have worked on other options with the Spring portfolio, crack support, CDS that we are going to mention a bit today. And also I have been working on the Kotlin support in Spring, and I continue to do that to improve and refine the Kotlin support to provide Kotlin support in addition to Java. And yeah, I think that's it.
I mean, you also, one of the, I think, most important efforts in the Spring history was Spring Kofu and
Spring Fu,
Spring Jafu.
I created this Spring Fu project that was basically intended to explore functional construct. Current Spring programming model is you can use various stuff. We started with XML, now we are using annotations, but I mean Java 8 bring Lambda, and there has been functional bin registration and functional web DSL in Spring. And so basically the idea was to extend a bit that and experiment around a more functional way of building Spring application. It's currently a bit stuck because it's pretty different from Spring Boot. So it's not the same programming model, but we may introduce later and work on more functional construct to be more first class in Spring. So yeah, I still have hope that we can basically continue to integrate more ideas from Spring Fu into the Spring portfolio.
Well, that's just it. Even already, it's done so much, right? I mean, it was, I think, very important in our GraalVM work. It was very important in our Kotlin work. It was very important in our approach to runtime efficiencies. I mean, it's just a very valuable effort.
It's true that we first found that it was possible to run Spring thanks to Spring Fu, because this was the first variant of Spring to run on GraalVM. And I think Spring Fu also allowed us to see that with the Spring ahead of time engine that we created later to basically transform during the build Spring annotation and reflection-based programming model to something more functional. It was possible to reach better performance, better efficiency, and to be able to run Spring on GraalVM, because without that, it was not possible. So yeah, I think indeed you are. It's right to insist on the fact that it has enabled various important features. Just I hope that in the future we could bring even more functional construct to Spring, and I think we will. Just it's a matter of priority and timing.
Yeah, I mean, and it's not it's Spring, but also Spring plus the language, right? So you have these two flavors, and I think these languages are still changing and being more amazing.
Jafu and Kofu, there was a Java and Kotlin variant. I'm still more convinced that for Kotlin that really makes sense and that feels natural. Maybe for Java it's a less obvious. But yeah, we'll see.
I saw a great tweet from our friend James Ward yesterday. Well, I guess it was, it's yesterday for both of us. It's just after midnight my time, so it was Monday. Let's put it that way. In the Americas, and his tweet was basically something like, it was something like, yes, Java has improved considerably, but let's not say it's the same as Kotlin. He's not. I know James. He would never. He's not kicking Java there. He's just trying to get people to be a little real here. I mean, you can't call a circle a square. They're not the same thing, and they shouldn't be called the same thing. It feels like. I don't want to speak for him, but Kotlin still is just a. If you're building these DSLs, I think you've got more power in Kotlin.
Yeah, I think James, I think I saw this tweet, and James is linking to another tweet that basically lists various Kotlin features where that Java don't have yet. I think the most important one is null safety, and Kotlin has been designed around null safety and not being afraid of null, and use it as an efficient way to express the lack of return value, for example. Java is moving forward, and there is some work to add some kind of null safety on Java side. But I mean, by default, nullness of Java type is unknown. And so it's not the same thing to start a language like Kotlin to say default is non-nullable. And if you want to get something nullable, you have to express it explicitly. While on Java side, they will need to not break the language, to keep the type that are basically with unknown nullness. And you will need to have a way to express that something is nullable, and to have a way that something is non-nullable. So you have basically three states on Java side, and there will be a bit more, it will be a bit more verbose, but I think that Kotlin really push Java to evolve, and Kotlin also progress on its side. And there is the Kotlin multi-platform support, which allow Kotlin to go outside of the JVM, and with WebAssembly and other technologies that may be pretty important in the future. So yeah, let's see.
Yeah, I mean, and indeed, I don't doubt that the people working on Java will do amazing things, but there's only so much time in the year. And there was a good quote from Brian Getz, who's the Java language architect, here on Reddit. I'll put this right here. Let's see if I can. How do I copy the? Did I? Okay. Before I lose it, there you go. It's a great quote from him, basically saying this work is. He says before anyone gets, he's linking to the null restricted and nullable types JEP preview from about a month ago when they announced this, or they came up with new information. And Brian Getz responds, he says, before anyone gets too excited, I would like to remind people that this is a very early draft, and that this feature is tied to the work going on in Project Valhalla. This is going to be a long road. And he says in parenthesis, it took a long time to even commit to walking this road.
Exactly.
And there will surely be aspects of this design that people will find puzzling. There's plenty of time to explicate the design choices. So basically, let's say that Java will get there eventually, and it's going to be just as good somehow, but that's not today. That's not tomorrow. That's not even this year, probably, or next year. So in the meantime, if you want that feature, and who can blame you? I want that feature. Kotlin does it really well,
Yeah, Kotlin does it pretty well, and I think it's a big commitment from Brian Goetz and the Java team, and I really appreciate that they start this journey, even if that will be difficult and long. There is also the gspecify effort, where I'm contributing for a few years, and gspecify 1.0 has been released. So gspecify is basically a set of annotations that are GSR 305 successor. GSR 305 was a GSR that never went out of incubation, and it's a bit weird. So we now have a formal set of annotations and specifications, and build tools and IDEs are being updated to support it. And I think in the interim, we can begin to use more gspecify annotations to express null safety, or spraying null safety annotation in our code base, and let the Java team to progress on that long road, and hopefully to get a reasonable compatibility between Kotlin null safety and Java ones. But I
And
really like the fact that they are moving on that, because this is, I mean, when you have developed with Kotlin, you basically can't forget that, yeah, this explicit null safety, it's just extraordinary. It allowed to express the lack of value
right.
without wrapping everything with optional or whatever. It's basically zero cost abstraction, and it turned yeah, a bad feature into something that is super useful and bring more safety to your code. So it's just super nice to be able to express
I
that.
couldn't agree more.
Mm.
I think if I look at the defaults in a language, I think the
Mm.
default choices, because Kotlin, you can write buggy, non-null safe, non-thread safe code in Kotlin. It's just a lot harder, right? Because the
Yeah.
defaults are the opposite. And so I think, if you look at some of the defaults in Kotlin, everything is final by default, although, oh, by the way, I have the thumbs up. That's nice. Anyway, everything is final by default. You have to open it to make it not final. Everything is public. This I don't like. Everything is public by default.
Yeah, as a framework and library developer, I'm not sure it was the right call, but yeah, it's good for me.
Yeah.
Yeah, I'm not sure. I'm not sure about that one, but
But on the other hand,
Mm.
just trying to give them a benefit of the doubt. On the other hand, if everything is final and immutable and not null, then maybe it's not such a big deal if you expose your package private types by accident, because there's very little to. Once your object is constructed, you're in a valid state, maybe more often in Kotlin. I don't know. I'm just trying to think about why they thought that was a good idea. But on the other hand, the null safety is like the default way to write code in Kotlin that you read is val, not var.
Mm.
And so val, I mean, you can use var, but it feels weird. It feels very ugly in Kotlin to use var. The IDE even makes it change the color a little bit, and so you get this very sort of val works. You can do val for everything. You can have long expression chains and assign the result of that to a val. So you don't need to have a variable and then initialize it in the constructor. You can just do val equals, val foo equals, and then a whole long list of dot apply and dot this and whatever, and dot with or whatever. So it just works really nicely. I love val in Kotlin, and so I think, I'm not saying it's the default, but it just, if you're a Kotlin developer, after very little time, you'll start using it by default. It feels very natural. So maybe that, I don't know, that nullability by default. That's that's a great feature, and it makes up for the public by default in my mind.
Yeah, and outside of the features, I think we need also to keep in mind that there is, I mean, we are working on the server-side ecosystem, and here Java is by far the leader, but there is also all this Android ecosystem where basically Kotlin is now the default, and it brings a lot of Kotlin developers on the market. Some people want to share their skill between mobile and server-side development. There is also this Kotlin multi-platform effort that can allow with Kotlin to switch outside of the JVM. So for us on Spring, we don't really care because we are really on the JVM
Right.
for sure. But for some kind of front end with Kotlin WebAssembly or maybe Google, I'm not sure what Google will do. Will they stay on the JVM forever, or will they move away a bit from that, leveraging Kotlin multi-platform? I don't know. But Android ecosystem is a big driver for Kotlin adoption, and let's see how that evolves.
And that's great for us, because their uses, they prize concise code, they prize backwards compatibility, they prize efficient code, and all of these things are very important to the Kotlin team. So they don't create bloated programs when you use Kotlin. I just had another question in my mind from what we were talking about a few minutes ago. If you'll forgive me, I want to go back. These J-specify annotations, I don't tell anybody, but I don't know why that works. Is there, like, we have in the Spring team, I know that there's an an @nullable in the Spring project, for example, and there are other @nullables in Jakarta and other places. And IntelliJ, JetBrains has their own one as well.
Yeah.
And I know that if you add that to the types and then you compile, if you run the code in IntelliJ, it'll show you little color codes to tell you that things are null or not. And also Kotlin will automatically, it'll understand that this is nullable, even though it's a Java class, it's a Java type. You've defined it in Java code. It'll understand nullability for those Java. It'll reuse or learn from those Java hints, right?
Yeah.
But so I get that. I get all that. But why does anything is there a root annotation, or is there anything in the compiler that knows about this, or
so
why does it work?
It works because originally, basically, we leverage the GSR 305 annotations and semantic. That means that you have Spring has null safety annotations that are themselves annotated with GSR 305 annotations that define the semantics, and basically IntelliJ IDE and other build plugin like NullAway are understanding Spring annotations because of the GSR 305 meta annotations, and this is the original reason for such support. That said, I think the various tooling, I think at least IntelliJ IDE now directly understands Spring null safety annotation because they are pretty widely used. And there is currently some ongoing discussion to see if we are going to stay on GSR 305 annotations, meta annotations, and semantics, or to see if we are going to switch on the gspecify, or if we just wait Java null safety, basically to go out of preview, etc. But we may have to wait several years. So another point I would like to make is that it's not just about annotations, it's also about semantics. The most important thing in gspecify, if you go to gspecify.org, there is a few annotations. Okay, you may think, okay, this is like GSR 305 or Jakarta once, but in fact there is specifications. We are in the process of making them up to date for gspecify 1.0, and we have been working 6 years on gspecify because we wanted to have clear semantics, and basically believe me, it's super hard. I mean, we have been working on that with Google, with Kevin Bourillon, who was at Google previously and now at Oracle. So yeah, a lot of nuances, a lot of complexity to be able to have a formal specification of what null safety semantics means for Java. Obviously, Kotlin is a huge source of inspiration, but so specifications are super important, and I really see gspecify as a drop-in replacement for GSR 305. Let's see how that evolved. And I guess the end game is really the null safety support on Java. And I guess Kotlin null safety and gspecify semantics will serve as a source of inspiration with the Java platform group.
I hope so. Well, does the Kotlin interop understand gspecify?
Yeah, because JetBrains and Kotlin team were part of the working group. So basically, there will be support, or there is maybe already support, I don't remember. In Kotlin compiler, in IntelliJ IDE, we are using on Spring Framework NullAway, which is a way to check null safety at build time, a bit like Kotlin is doing, a bit like Kotlin compiler is doing, but with Java code. And you can use NullAway with your project. So if you want to have full null safety with your Java project, you can either use Spring null safety annotation or gspecify, use NullAway plugin. There is integration in Maven and Gradle. NullAway.
From Uber.
From Uber, exactly. And that allows you to get basically Kotlin-ish null safety with your Java code base. Spring Framework API are annotated. I think Spring Data ones are annotated, and we are discussing with other Spring team to bring null safety annotation to other Spring projects in order to allow Spring developers to have a full null safe API. And if you are adding null safety on application, you get the same safety that you have on Kotlin. So that's good.
That is nice. See, that makes living in Java just so much more pleasant.
Yeah. That's
It's
super.
that's a
Yeah.
and I'm grateful to the JetBrains engineers and teams because they are, of course, there's two different sides. There's the Kotlin support and the Java support, and then there's the IDE, and it looks like they're trying to help in all the different areas
They're
there.
really trying to help, and they are doing a very good job to promote null safety. They don't want to keep it just for Kotlin. They just want to just bring it to Java and the wider scope of projects. So that's super kind from them.
Very cool. Yeah.
Mm-hmm.
All of this makes it so all of this stuff makes things more efficient, obviously, and I don't know, but I have a question. Do we know how useful final variables are in a method? I know in a class, is there some wisdom about that?
Related to
You
null
might,
safety?
yeah. Well, also just in general, I just keep
Yeah,
thinking about it, like, do you
with
do
null.
final var or just var?
It depends, but yeah, variable initialization, especially static ones, there are some challenges related to null safety. So you may want to, yeah, be able to express initialization in a different way. I think there is some discussion in the Java working group to basically maybe bring more new capabilities to be able to avoid this initialization issue where you could have basically at the beginning your variable may be null and it may be defined after. So this is why we have this lazy behavior in Kotlin to be able to
Late in it.
walk around late in it, to walk around that. So yeah, but I don't think in Spring Framework when we introduced the null safety annotation, we did not add to make everything final, or there is not a huge impact on that. It just, the biggest work is to ensure consistency across your code base, and basically if something is returning nullable, so default is non-nullable, nullable return values and parameters are expressed explicitly, and you are also defining null safety annotation on fields, and you try to make everything consistent in your code base. And it took so many commits, so many time to fine-tune everything to ensure consistency, basically. And if something is returning something nullable, you need to check that result explicitly and throw an exception, or deal with the case where it is null. But we didn't add to make everything final in Spring from our code base to add null safety.
Okay. I think about the factory beans in Spring, right? Because I don't use factory beans anymore, but we have a lot of them because of the old days. And in the factory bean pattern, you have a bunch of setters, right? You don't have, it's not constructor initialization, it's setters. And so everything is nullable, right? It has to be because you have to be able to optionally set A and B or A or C or, whatever.
Yes, we may want to favor constructor-based injection, and here,
for sure,
indeed, you can use final fields, etc. Yeah, constructor injection is more null safety friendly than setters, for sure.
Yeah, and I know we have in Spring over the last 10, 15 years since Java configuration in 3.0 in 2009, we have more builders, instead of factory beans, and more constructors which have multiple parameters as opposed to the Java bean constructor with just a parenthesis and a bunch of setters. And so moving Spring to support this, it's taken decades, to promote this more valid initialization by default, of which I think nullability is a huge part of it.
But we can allow project to basically use that kind of pattern more easily without having to change everything in Spring Framework. So what we try to do is on application side to promote constructor-based injection. And basically you will see quite a consistency between Kotlin and Java idiomatic code with this kind of null safety effort. And this does not require to change everything in Spring because it's mostly annotations, and the majority of the contracts are user defined, and the ones we provide are mostly null safety compliant. So we should be fine.
I love it. Yeah, no, it looks great today. I just don't think people understand all the work that has gone in. It's amazing.
Yeah.
So okay, so now you've got with null safety, and I mean, there's a couple of features out there that are in the language that if you use them, the compiled code is safer and faster, right? One thing that I really like to, whenever I can, I try to use these days. I didn't use it before because it felt very ugly, right? But if I can use a smart switch expression today over the visitor pattern, or polymorphic dispatch, whatever, if I can use smart switch, especially with cases, with the pattern matching, that bytecode is a lot faster than the equivalent if else branch. So it feels very nice to use it, right? And also, I don't have intermediate variables, so I can do var x equals switch. So that's very nice today. Obviously, final class variables feel very nice. There's some things that are just, if you write them in the Java code, the code that is compiled is faster. But then you're done. And then at that point, for the longest time, there was a few things you could do at runtime in the configuration that give you small benefits, like the garbage collector maybe would be a little different or whatever. But now, in the last several years, I've noticed that there are some really big things that we can do to the running Java programs that are, first of all, available outside of Java, like Project Crack, like GraalVM, like what's the other one?
CDS.
Well, no, yes, of course, but thinking of something else. But anyway, CDS is in the JVM, right? That's different from Crack and GraalVM. And these are very different ways of thinking about running your Java code. They're not, they have a few things in common. They all require a training. Well, GraalVM, I guess, does not. But if you use profile guided optimization, then there's a training build. And then you get this runtime build, and then the runtime is much better. Really, really impressive results. Where does Spring land in all this, right? Like, where are we going? I don't know. I mean, there's so many options. What's the choices that people have today? What should they look at?
Yeah, that's a good point, and I try to provide a bit more guidance these days, at least sharing my opinions on that. So Spring Boot 3 has introduced official GraalVM native image support. So the goal is to compile Spring Boot application to native executables. I think that's really bring very different characteristic in terms of runtime for Spring application. So first, there is a price to pay. Okay, so you have to pay a price in terms of long build times. You have to pay a price in terms of Java compatibility, because some semantics are not exactly the same, so you have to provide ints. And Spring is doing a pretty good job to infer most ints, but for your application, for your libraries that are specific from your company, you may have to provide some ints to make it work. But if you pay that price, basically your startup time is 50x faster. So really, you start your application in a few milliseconds. Even big ones. You get lower memory consumption. You get peak performance available immediately because there is no JIT. Everything is precompiled, and that's it. So it's super interesting, and we see quite an adoption. I think we get some figures at last Spring I/O, and I think, I don't remember exactly, but it was more than 10 or 15% of Spring developers having at least deployed one native application on production. That doesn't mean they are deploying all application on production with native, but that's already a big market share, because I mean, there is millions of Spring applications in the world. So when you get 10% of Spring developers trying a technology and deploying in production, I think that's pretty big, and that means that I think the native support in Spring is quite successful. That said, native is not for everybody. I mean, I'm talking with a lot of customers. I'm sure you do as well. And when you have big applications with a lot of legacy libraries, you don't necessarily have the time, the energy, or yeah, I mean, and maybe you don't care to have a startup time of a few milliseconds and you don't want to pay that price. So I think native is really here to stay, and that's a super nice technology that keeps improving. We have weekly meetings with the GradVM team. We continue to collaborate. We work on this GradVM reachability metadata, which brings ins for various libraries, and we collaborate with the open source ecosystem on that. But in parallel, yeah.
Oh, sorry.
Go ahead.
In 2022, we released the GraalVM Spring Framework 6 and Spring Boot 3 was October, November of 2022. So 2 years ago almost. And I think the GraalVM team did a survey on Twitter, which is, let's not talk about Twitter, it makes me sad, but they did a survey asking what percentage of people this is at GraalVM, right? What percentage of people are using, they're asking, which of these frameworks, which one are you using GraalVM, right?
Yeah.
And it was like, it was just a few weeks or maybe a month or two after we released Spring Framework 6 and Spring Boot 3.0, and already Spring Boot was in the lead compared to all the other frameworks, right?
Yeah, it's a similar,
like you said, a small percentage is a huge number.
Yeah, exactly. This is the same that we see on Kotlin. Like by far, Spring Boot is the most used server-side framework, much more used than Ktor or other Kotlin frameworks. And same for GraalVM. We provide, I think, a pretty good native support. And yeah, Spring is the leading framework for developing GraalVM application on server side by far. And that's good. So we continue to support that. We continue to collaborate with the GraalVM team, and we are pretty happy about it. But we need to provide efficiency improvement for the 90% of remaining developers that won't necessarily jump to native, that don't want to pay the price of long build times and compatibility issues. So with the JVM, what kind of technology we can use to improve efficiency? And when I mean efficiency, I'm talking about reducing the startup time, reduce the memory consumption, and basically also reduce the warm-up time. So reduce the time that we get to get peak performance. And there is basically, we have explored two options. So in Spring Boot 3.2, we have introduced support for crack, which is coordinated checkpoint at restore, I think, as the acronym. So crack is interesting because it allows to reach the level of startup time that you have with native. So in just a few milliseconds. So it sounds amazing, but in practice it's more complicated than that, because first it's an experimental project. You have a different JVM, so crack is not included in default JVM. And basically, you need to do a training run. So you need to start your application, and Spring provides some support for that. But it's a bit brutal. Like you are serializing everything you have in memory is serialized on disk. It's based on a technology that is called CREU, which is a Linux technology. So it's Linux only. It's going to serialize everything you have in memory on disk, including your secrets, your password, whatever is stored in memory. And I think on the Spring team, we wanted to support a technology that allows to ship basically a self-contained container that starts faster. And with crack, since we get the secret potentially we get the secret on the snapshot file, since there is some lifecycle issues, because when you start an application after the training run, you are not doing a real start, you are going to resume the execution. That means that there is some sockets to reopen, some files handle to reopen, and even if Spring support it, the ecosystem don't necessarily support it. We don't necessarily have the methods to reopen the thread pool, etc. So, we had quite a lot of hope for crack. It's still interesting, and we have some support in Spring Boot for that, but in practice, we see a lot of people struggling with adoption because there is some blocking point in the road that does not allow to leverage it. and so 1 or 2 years ago, the Java platform team began to work on Project Leiden, which is basically an effort to improve the runtime efficiency on the JVM. And they did some work with just regular CDS technology. CDS, class data sharing, is a technology that is quite mature. I think it's integrated in the Java virtual machine for many years now, but it's mainly used at to optimize the loading of the JDK classes, basically, and it's not used for your application or your libraries. Because it requires quite a lot of it requires a training run, and it requires to fulfill a set of constraints, like it's not a good fit with executable jar. The Spring Boot executable jar, it's nested jar, and nested jar are not a good fit with CDS. There is a set of constraints you need to fulfill, and basically it was too hard for people to use without a proper support. And what we have done in Spring Boot 3.3 is that we have been working on specific support for CDS with 2 features. Basically, the capability for an executable jar to self-extract to a CDS-friendly layout. So basically, you run a command with the Java command, and the executable jar with a self-extract to a CDS-friendly file layout. And
Is
also
this the jar mode?
Yeah, exactly.
With
the jar mode tools. And there is also another feature, which is basically the capability for build packs, which is the technology used by default on Spring Boot to create container images, to automatically perform the training run, ship the CDS archive with it, and basically you get a self-contained container image that is able to start faster, up to 2x faster startup, and reduce the memory consumption, basically.
And I don't think people. I think people are watching this. It's like 9 o'clock or 10 o'clock in France, or 8 o'clock, 9 o'clock in the UK, and it's midnight here. I don't think people have had enough coffee to understand exactly what you just said. So I'll say it again. When you use this feature that's in the JDK already GA and already in Spring Boot GA, you can get your application to start up twice as fast. It doesn't involve any changes to your code. You just upgrade your JDK, and then you can send the Spring team a little letter saying thank you for making my life better. I mean, it's just twice as fast.
That's a good summary. Yeah, that's a good summary, and it's available in Spring Boot 3.3. So the main thing is that you just have to upgrade to the latest GA. You just have to use your current JVM, and basically you enable a flag, and that will work. You have very little side effect, just small side effects with early database connection, but you can basically, with 2 lines of configuration, you basically work around that. And so yeah, I think that's very good, because the improvements are real, maybe less dramatic than GraalVM, like it's not 50x, but they are significant, and the price to pay is close to nothing. I mean, you just need to upgrade to the latest Spring Boot, enable the flag, maybe add 2 lines of configuration, and that's done. So I think the value proposal is very different. You have GraalVM that allow dramatic improvement in terms of startup time, memory consumption, but you have a price. There is a price to pay, and there is this let's enable efficiency features with Spring Boot as a flag. And this is usable in most of people projects. So this is, to me, this is a no-brainer. There is no really big drawbacks to use that kind of feature.
You can script it. It's one of those things where you don't have to be involved. This is one of the things you can put in your pipeline.
Yeah, it's a flag.
It's a flag. Well, you have to run the program once. You have to run with the jar mode stuff. You have to get the tools, but it's all scriptable.
So if you are using Buildpack, it's really a flag plus some configuration.
Yeah.
And if you are not using Buildpack, you can still, basically you will have to perform the training run, etc., manually, but it's doable, and with your Dockerfile or other technologies, you can also use it. So you are not blocked. It just, if you are not using Buildpack, it's more work. obviously.
Sure.
But there is some facilities that help developers to leverage that. So I think that can really target every Spring developer, Spring Boot developer, basically.
Yeah, and I've done it with build packs and I've done it without. Even without, I mean, you should use build packs. Obviously, that's a great tool to get to production. But if you just want to see it, you can do it entirely in batch. You don't have to be involved. You can take a jar and then run the thing, and then on the other side is an app that will start up twice as fast, completely automatically, which it's just free. It's free scale. Thank you, Java.
And it's interesting to see that it's possible because there is a feature introduced in Spring Framework 6.1 that allow to basically not start fully your Spring application. It will just basically begin to start your Spring application to load all the classes to make CDS happy. So CDS know the classes of your application, your libraries, the GDK, etc. But it stops the application before starting the Spring lifecycle. That means that remote services will not be reached, except some early database interaction, but except that it's not fully starting your application. This is why you can do that on your CI/CD platform. You don't have to have everything, database, production, etc. Available. The goal is to perform this training run without reaching external services in order to be able to perform it with Buildpack or in your CI/CD platform.
Is this sort of like the same life cycle we use for AOT mode?
It's not the same life cycle, but it's conceptually it's a bit similar. We want to start partially the Spring application to perform some optimization, but we don't want to fully start the application to not contact the remote services, etc. Spring IoT is stopping basically before what CDS is doing. Because we are with Spring ahead of time optimization. By the way, they can be combined with CDS, so Spring IoT and CDS work very well together. Spring IoT is not going to instantiate the beans, while CDS training run will instantiate the beans to be able to load the various classes that are needed. So the CDS training run is slightly more involved than the Spring IoT one, but again, it's almost side effect free. You may need 1 or 2 lines of configuration to prevent early database interaction. You may also have to, I mean, if you are using Flyway or some libraries like that, it's not really a good fit with training runs because it will try to reach your database, etc. But yeah, there is not much more side effects than that. And CDS is a very mature technology. I mean, it has been integrated in Java since Java 9, I think. And it's only supported in Spring Boot 3. So basically in Java 17 or Java 21, CDS is pretty efficient. And that's available right now. So that's good.
3.3, which just came out, was that the one before Spring IO? Yeah, it was.
Yeah, I mean a few months. Yeah, I mean 2-3 months ago. I don't remember, but we are already at the latest
almost
GA
6.4.
is 3.3.3. Spring Boot 3.3.3 has been released.
Right.
So it's yeah. I mean you can really use it on production, and that works pretty well.
Wait, so it's I just realized we're in September. October, November is Spring Boot 3.4.
3.4.
So actually,
exactly.
We're more than halfway there to the next version. So it's out there already.
Exactly, it's out there, and there is various patch release to fix various bugs. So it's this is why I say it's really usable in production. And this CDS feature is really interesting because this is not the end game. We are collaborating with the Java platform team on Project Leiden, which is CDS successor, to simplify. And that will bring even more benefits, like even faster startup time. So with CDS, we are at twice faster startup time. With Project Leiden, we are at 4x faster startup time right now. It will also bring, it will require a more involved training run, but it will potentially bring what I call AOT warm-up. So basically, with the JVM, when you start it, you need to wait some time to get the JVM hot and get the peak performance. Project Leiden will allow to warm up during the training run your application. and store this warmness. That means that when you will start your application with Project Leiden, it will be it will already have some kind of warmness. So maybe not peak performance available immediately like native, but you will have a much faster warm up, and also it will allow to reduce the size of the container image. So that's going to bring more benefits basically.
Is CDS then just loading the metadata about classes, but not actually jitting the code? Is that the idea?
Yeah.
And
basically,
so Leiden could jit some of it, maybe.
Leiden is adding. So basically, Project Leiden. This is a pre-main feature we are discussing here. Is basically reusing what CDS is doing, but it's extending the scope. So instead of just optimizing the loading of the class, it will also include a cache code that will store the warmness of the JVM and various other kind of optimization, like basically cache the classes that are not present in the class path and cache various other things that will allow to basically reach a new level of performance. So it's a kind of generalization of CDS that is caching more stuff and doing more optimization.
Do we have timelines on Leiden, or is that still very much out of scope at the moment?
I don't think so. We have early access builds that are available, so that's a nice step. But I don't have any timeline. I don't think the Java platform has communicated any timeline. So just I can say that the working group is working quite a lot and efficiently, but I'm not sure when that will be in preview or basically GA. It's too early to say. But the good thing is that we have CDS right now, which already bring a lot of benefits. And the feature that we have developed in Spring Boot, it makes Spring Boot Project Leiden ready, basically. We will add more, and there is new challenges because we need to potentially warm up the application, and not everything is doable at Spring Boot level. So there may be some kind of platform integration, because at some point where you need to warm up your application, you may need some kind of platform integration. But I mean, we are working very closely with the Java platform team. I will have the pleasure to co-speak in the Project Leiden talk at Devox with the Java platform team. So it's really show that there is a very close collaboration between Spring team and Project Leiden team, and it's super cool because we are working with the Java platform team on optimizing Spring applications and others, but Spring has so much market share that basically working on optimizing Pet Clinic and other Spring application is a very good use case for the Java platform team. And we also bring more, we are closer to the customers of the enterprise use cases. So I think it brings a lot of added value for the Java platform team to have this kind of collaboration.
So cool. Oh, that's so cool. The work around Leiden, we've been talking about application startup, which is incredibly valuable, I think, in the cloud, because most of us are not Google. We don't need to have instant on, but I think there's still some very nice benefit to having predictable startup latency, to having that reduced. There's another dimension which GraalVM does serve, which is the RAM. To what end does Leiden help us that? I know CDS, not really a huge difference.
CDS help a bit. We see 25% reduction. I mean, when we combine CDS and Spring IoT, we see 25% reduction after startup. If we take CDS alone, that's maybe 10 or 15%. So not huge, but that helps.
Yeah, it does.
Project Leiden for now only provide meaningful data points for startup time and warm-up time. Optimization for reduced memory consumption has not been done, so I can't share anything about that. Our ask to the Java platform team is to get at least the level of improvement we get with CDS, so do not have regression here. And if Project Leiden can do better, it will be good. But for now, I think they're really focusing on reducing the startup time and the warm-up time, and memory optimization will come hopefully later.
Yeah, no doubt.
Yeah, I hope there will be the same or even better optimization than CDS, hopefully better, but we are not here yet.
And I mean, I think for most people, having the ability to scale up when you need to quickly is more valuable
Yeah, and
than
talking about
RAM, because we can.
talking about what you said about startup time, I think there is. So the first use case that I have in mind is when you deploy a Spring application on a cheap server. I mean, we we see people deploying Spring application on, and I would not recommend that, but on half of a virtual CPU and crazy low level of RAM. It's
Right.
make it possible for Spring application to start reasonably fast on this kind of very cheap, very cheap servers.
Yeah.
And just to get a good level of just to operate your application in the good way and do not have to wait more than 10 seconds to get your application startup. So being able to target very cheap server with a reasonable startup and scale up time, I think is very important. With Project Laden, we may reach a level of startup time that may allow us to scale to zero with the JVM. Like if we are able to start your Spring application in less than a second, if you have a platform that supports scaling to zero and consume and cost nothing, where when basically this is the night and on your small back office nobody is using this app, yeah, let's make your app free when it is not used. So we may
Right.
reach this kind of level of performance right now with CDS. I would say it's mainly, yeah, being able to use cheaper server and have a better operation quality for people dealing with your apps and production. And it's already a
Right.
big thing because that makes your application a good Kubernetes citizen. We may reach a level with Project Laden where we can scale our application to zero, like with native. But yeah, let's see.
Yeah, I can't wait. All of this is very, very exciting, and it's very interesting to see the Java team. Uh, it's not. I mean, did you see some of those videos from the Java Language
Yeah,
Summit
yeah,
recently?
sure.
Oh, some amazing stuff there, and a lot of it was to do with performance. I mean, yes, there's some syntax, like we talked about, initialization. Soon you'll be able to do it before super, things like this. They're gonna have a better model for initializing things before calling super and all that. And there's some other nice things in the syntax and the language, but really the stuff that's like, oh, so exciting to me is what the platform can do. What the JVM can do for me. That is the multi-billion-dollar gift that the JVM community has. And this this Laden stuff is, again, you just add a switch and free performance. Just I don't know, just amazing.
Yeah,
And that's also great for Kotlin too, by the way. It's good for everybody when this stuff works.
I think there is a very healthy competition in the JVM space. I mean, Kotlin versus Java, and they are pushing the boundaries. There is,
Sure.
yeah, I mean, GraalVM and Project Laden, I mean, they are kind of working together, but they are also kind of competitors because this is two different solutions. Hopefully, they will converge at some point, but right now it's really two different tracks. There is Project Vala that will bring some new construct that will also, again, bringing more zero-cost abstractions to the language, maybe inspired by Rust
Yeah.
and other languages. So I mean, there is virtual threads. There is upcoming virtual thread improvement to reduce current thread pitting issues that we have with some constructs. So yeah, I think the ecosystem is very healthy. There is some kind
Yeah.
of healthy engineering competing solutions that are pushing the boundaries, and in the Spring team we try to basically also evolve the framework to leverage those new features while not breaking backward compatibility. And believe me, that's sometimes a big challenge, but yeah, we try to.
I that's what I'm trying. Yes, I start all of my presentations with something like, "There's never been a better time to be a Java and Spring developer," because what you just said is, oh, it's so true. It's not just healthy. I think it's the healthiest it's ever been.
Yeah,
I remember
I
in
totally
the
agree.
90s.
Mm.
In the 90s, we had JIT. People don't know, but JIT didn't happen in 1.0. That was like 1.1, right? Java 1.1. That's when we got JIT. That's a huge deal, right? Just-in-time compilation came later. huge, right? Java 5, we get generics, and Java 1.2, we got Swing. I mean, it's some big stuff. But then in the last 5 years, we've gotten GraalVM, we've gotten virtual threads, we've gotten the app CDS stuff, and Laden. We got VAR, we got smart switches. I mean, more things that I can even remember, all in the last 5-6 years. And it's still going. It's still going. Valhalla, like you said, Laden, like you said, all these things that are going to be even more impactful are just on the horizon. Just crazy,
I think some of the other technologies become to be a bit jealous. I mean, if we are, there is still some work, okay? Because Project Leiden need to basically reduce the footprint of Java, which is bigger than other technologies.
Sure.
But if they manage to do that, if we get basically virtual thread usable by default by removing the thread pinning issues and making it providing lightweight threads for everybody. If we get null safety, if we get basically project Vala, value types, and other improvements without breaking the ecosystem, I think that will be a pretty exciting place to be. Yeah, and other technologies will have difficulties to catch up because I mean we keep the advantages like crazy high performance where the JVM is hot, a stable ecosystem, a good trade-off between dynamicity and static aspect of the language. So yeah, I think that's pretty exciting time to be a Java developer. Yeah.
And you mentioned Valhalla. One of the, I mean that some of that stuff is already kind of here, right? The vector API is, I think it's here now, right? It's already in the JDK. And what's really interesting to me is with Valhalla is really efficient SIMD, efficient alternative hardware for computation, right? And this is very, very important in the world of AI, we just talked about, right? If Java, I mean, Java's already very good at, I would like Rod, like our friend Rod said on the stage, it's really good at integration, right? It's if you want to consume AI, there's nothing better.
Yeah, this was a very good point that Rod said. He was saying you have the feeling that maybe Python is everywhere in the AI world, and Python is good to experiment. But if you want to build, and we are at the time where we begin to build real AI enterprise application, Python is likely not the right choice. I mean, the dynamicity of the language and over aspect, performance, etc. So yeah, I think Java is a pretty good card to play with Spring AI and stuff like that to build enterprise application based on the AI ecosystem. And I'm pretty confident in what Rod said, that Java and Kotlin can be really successful in building enterprise application using AI services, much more than Python will be, for example.
And by the way, you saw, of course, he was using Kotlin for his demo, which I thought was super good.
Yeah, I'm pretty excited to see Rod excited about Kotlin, etc. I think he was deep in the Scala ecosystem at some point, and he seems to really appreciate the Kotlin support in Spring. So I had the opportunity to talk about that with him at Vegas, and that was nice.
I imagine that you felt talking to him as I feel talking to you. Just very grateful. I'm so grateful for everything you do. I really appreciate you taking the time to explain all these amazing things. I know that I know that there are other more important things that you have to work on, and so when you take this time, it's really, really, really appreciated. If people have questions, are you on the internet? And if so, do you want to be found? And if so, where can people find you?
Yeah, so I have a website, seb.deleuze.fr, where basically I have links to my various social media accounts. But otherwise, just try to find Sebastien Deleuze on LinkedIn or sdeleuze on Twitter /X. I'm also.
Are you French?
Yeah, totally. But yeah, on this seb.deleuze.fr, you will have all the links. Also to Mastodon, I have a Mastodon account. I try basically to post to LinkedIn, X, and Mastodon. The same kind of content. So choose your
Nice.
field.
Oh, there's some good stuff here. Yeah, okay. I'll check it all out.
Yeah, it's my also WebAssembly blog post. I'm also a big fan of WebAssembly, and so on my spare time, I work a bit on that with the Colton team, etc. But yeah.
What can you tell us about that? Is there anything we should know? When will it take over?
It takes a bit more time to get enterprisey WebAssembly basically taking off, but I see very good evolution, and Kotlin WebAssembly is pretty interesting. Safari has recently chose to add support for WebAssembly garbage collector, which was the main missing piece. That means that there will be full support for WebAssembly WASM GC and Kotlin WASM on Chrome, Firefox, Safari, etc. And this is going to unlock a lot the ecosystem. So now we are working Kotlin WASM and WASM GC support in WASM Time, which is the most used server-side WASM engine. And when that will be available, they are working on that. I think that will be a pretty exciting time for WebAssembly and specifically the Kotlin WebAssembly support. But it's still the early days, and the ecosystem need to mature a bit more.
I saw earlier this year, I think maybe it was you with whom I was speaking, there was a WebAssembly engine written in Java.
Yeah, so there is maybe Chicory.
Yeah, that sounds right.
Yeah, so there is Chicory, there is WebAssembly support in GraalVM, and yeah, that I think that's interesting for user-defined functions. When you want to have those user-defined functions written in various language, but again, WebAssembly component model and WASI need to evolve a bit more to be fully usable in various languages. So I'm still excited about WebAssembly and still bullish about WebAssembly. Just we need to be patient because this kind of standard take a bit more time than expected to mature. But I see very nice progress, and I think it's going to be maybe a future challenger for the JVM. Let's see.
Fingers crossed. All right, my friend. Thank you so much
Thank you,
for your time. And everybody else, thanks for hanging out. Have a great day, afternoon, and evening. Goodbye.
Bye.